What I'd like to do now is demonstrate how to uh, conduct several non-parametric analyses using Stata. And to do this, I'm going to use the growth and enhancement data for Montana students. And the data that I'll be using to illustrate these analyses is gender, high school GPA, criterion referenced fourth grade math scores, high school GPA for uh, two different classes, class 1 and class 2, and then pre-test reading and post-test reading. The first analysis that I'd like to demonstrate is comparing gender on high school GPA. Now remember, we use non-parametric statistics when the assumptions of normality and homogeneity of variances are violated, and in the case of correlations where the assumption of a linear relationship is violated. So when we compare gender, male and female, on high school GPA, typically we would use a independent samples t-test. But for a non-parametric analysis, what we're going to do is we're going to use we'll go to summary, tables, and tests in non-parametric. We'll use a Mann-Whitney U test, or in Stata, the equivalent is the Wilcoxon ranked sum test. And so this is a very easy test to run. Our variable in this case is high school GPA, and our grouping variable is gender. And then we'll submit that, and we'll toggle back to our output, and we can see that the rank uh, the sum of the ranks for males is 25,685, and for females is 19,464. So this difference is significant, and we can see here that our probability is much greater, or much smaller, I should say, than 0.05. So males have significantly higher GPA than females. Now the next analysis I want to show you is the case where we have a pre-test and a post-test. So in this case I have pre-test reading and post-test reading scores. And normally we would use a paired or a dependent samples t-test. But in a non-parametric world, we can go to summaries, tables, and tests, and non-parametric tests of hypotheses, and we'll use the Wilcoxon matched pairs sign rank test. And so our variable in this case is pretest, and our comparison variable is post-test reading. And so this is the variable that's being compared, pre-test and post-test reading. And so we submit that, and we see that the sum of the positive ranks compared to the sum of the negative ranks, or the difference between pre and post tests, is much greater. And so our probability of significance, we do have a significant result in this case, 0.000. So again, this is very much less than 0.05. Now the only thing is, to get a reference to see how males and females differ, is we like to see what the means are. So we're going to have to go up to get our summary statistics, and we can put in pre-test and post-test reading, and then we can see that the mean for pre-test was 282 and post-test was 290. So this difference between the pre and the post-test was significant. Now a third type of non-parametric statistic that you might be interested in conducting is when the assumptions for the ANOVA analysis are violated. So again, we have a non-parametric one-way analysis of variance. And so we can go to our non-parametric test of hypotheses, and we go to the Kruskal-Wallis rank test. That's the equivalent, or the non-parametric equivalent, of the one-way analysis of variance. And so in this case, what I want to do is compare class. There's 4 classes, and I want to compare them on high school GPA. And so when I come back here to my window to do the high school, do the comparison, my outcome variable is high school GPA, and my groups will be class. And so when I run that analysis, I can see that I get a output that gives me the rank sum for each of the classes. And what this is telling me is that the probability that there's one class that's significantly different from another class is not significant, because this value is greater than 0.2927. So that's the Kruskal-Wallis for when you want to compare more than 2 group means and use a one-way ANOVA, but the assumptions for the parametric ANOVA are violated. The last procedure I want to demonstrate is when we have ranked data, and I need to open up another data set for that. And so let's see if I can find that. Okay. So in this situation, in this data set, I have 2 judges. And what they've done is they've ranked students from high to low. So they've ranked them from the highest performance to the lowest performance for their science fair projects. And so we're going to compare the 2 judges to see how the rankings compare in terms of how consistent these judges are in comparing these students. Now, normally you might consider doing a Pearson correlation, but in this case, since we have ranked data, we're going to use a non-parametric correlation. So we can go to statistics again, summary, tables and tests, non-parametric, and then we can go to the Spearman correlation for ranked data. And so in this case, we simply put in judge 1, put in judge 2. We like to have the correlation coefficient, the number of observations, and the significance level. And then we go OK. And we can see that our correlation between judge 1 and judge 2, there's 10 observations, and the Spearman correlation is 0.82. So that's a large correlation. So these judges are fairly consistent in terms of the way that they rank students in terms of their performance on their science fair projects. Well, this was just a short little tutorial on running non-parametric statistics in Stata, and I hope it's helped.